Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. So Lakshman, you want to mute yourself? Yeah, thank you. Okay, so today I'm going to discuss about Elastic Search. So basically, there's so many names we have for this. Uh, Initially, we started with Elasticsearch, and the company name is Elastic. Don't get confused. Company name is Elastic, and the most important software which we have is Elasticsearch. Okay, and then followed by Logstash and Kibana, and there's one more component which we have a Beats. So when we say Elastic ELK stack, then these four software is coming. Though we call it ELK, but I think we can call it ELBK also. That's not a problem. So Elasticsearch, Logstash, Kibana, and Beats. So this way call it Elastic ELK stack. Sorry, not Elastic stack. And what has happened over the period of time? Elastic has started transforming themselves, and they started optimizing it. So those stuff anyways we'll learn, but this, if you see ELK stack to convert to Elastic state, so what they did in Elastic stack, they had a very great integration between these two tools. Okay, great integration. So earlier they were calling ELK stack. Now, I mean, and later on they started calling Elastic stack. So Elasticsearch, Logstash, Beats, and Kibana now become Elastic stack. Now all of these software which you see here, Elasticsearch, Logstash, Beats, and Kibana, is a free and open source. Yeah, there is a paid version available. Right now, I'm not getting into that discussion because you don't need right now those part. Okay, and why we have this software? Why we have this software? So this software we have it primarily for log management. Yes, primarily for log management, log analysis. Now, those who are coming from the background of Splunk, then you can say Splunk versus Elasticsearch, right? So like this. So this is the software which we are going to discuss today. Okay, so now I want to discuss about this image a little bit in detail, and then here now what has happened, uh, here you have a Kibana. Now this part is basically for dashboarding. Yes, yesterday if you remember we learned dashboarding solution which was Grafana, right? So yeah, Kibana, you can compare Grafana versus Kibana, both supported the same way. So Kibana was developed by Elastic, Grafana was developed by Grafana, which we know that now. So this is the dashboard solution for visualizations and management. Now where the database will be stored. So that is where that here we have a Elasticsearch. So here you can store the index. Also, this component can be used for searches also. Okay, and analyze also. So everything is been done by Elasticsearch, right? Now something similar which we had yesterday, and instead of Elasticsearch we use Prometheus, right? And same way, so Prometheus was for store and PromQL for search and analysis, correct? So in this case we have Elasticsearch for the storage and DSL. Okay, DSL query language we have for query, search, filtering, and all kind of things, analysis. So this is the dashboard, this is the one. Now the question is, who will send the data to Elasticsearch? So if you remember, then the Prometheus, it was sent by, I mean, it was basically exporter, which will be enabled and then pull will happen. But here it's not a pull based mechanism, it's a push based mechanism. So we have a beats here. Now what is beats? So typically the name we call it a beats, but simple way we can call it agent. Okay, this agent. Okay, so now what we have, I want to show you number of elastic beats, because there's no one agent. If you are thinking about, okay, there's one agent. No, there's so many types of beats we have. We need to understand this one. Okay, so it's like slowing down. Hmm. So now if you see that here, see here, so many types of beat we have: file beat, metric beat, packet beat, winlog beat, audit beat, heartbeat. So now if you want to understand, let's say you want to collect the logs, so we use file beat. If you want to collect the Linux metrics like CPU, RAM, disk, network, then for that we use metric bit. If you want to collect the network data, then packet bit. Windows data, Windows log, event logs and all, winlog bit. Here if you want system audit logs, audit bit. And heartbeat will check the uptime for the machines and URL and kind of things. So these are the different executable for different purpose. So now when I say beats, and at a high level we can call it agent, but we have a multiple beats actually. Okay, so this is something. Beats collect the data from the different sources, different kind of beats, collect the data and send it to Elasticsearch. And Elasticsearch, you have everything. And Elasticsearch, just like Prometheus, you can run on the Prometheus, right? Same way, DSL directly you can run on Elasticsearch directly. You don't need Kibana for it. Something similar we had in Prometheus also, right? UI Explorer. So you can run this. API is API call. Elasticsearch is available on API, same way. So, but we need a greater visualization tool, right? That is where then we need a Kibana, and then Kibana will be configured with this one. Arrow is important, okay? You need to understand the arrow, and then this is something and you will work with the Kibana and to explore for dashboarding, for alerting, many other features we have in the Kibana actually, free version, then cloud version, enterprise versions, and also on. And that is how it works. So far so good. Any questions? Any doubts? Any questions? Any doubts? Hello, I'm
Rajesh,
audible,
this is
right?
Lakshman again. Just a question: how this is different from the OpenShift version of Kibana, Elasticsearch, and the ELK stacks?
Okay, so OpenShift is a basically you can say platform. Okay, and OpenShift is like a platform which you can set up in your environment, and on which you manage a multiple Kubernetes cluster for the running the applications. It can be in production, it can be in a staging, it can be in integration, whatever it is. That's a fundamental use of OpenShift. But because you are doing everything on the containers now, Kubernetes, so OpenShift have enabled this Elasticsearch, Prometheus, and hundreds of different tools like Jenkins. Everything you can install just like a service. You want it, you get it, just like that.
Hmm.
So technically, it's not a difference. The same thing. It's just like OpenShift will host the software for you, and you can use it. They will manage it. Something like that. Something like that. If you want to use Elasticsearch on AWS. So AWS has introduced one service which is called Open Search. So it's the same, but the thing is, this is a cloud hosted one, something like this. Okay, Open Search AWS. Here it is. This is the one. Are you understanding me?
Yeah, yeah, got it.
Yeah. So same, I mean, whether you learn, see, ultimately the where the tool is hosted, that is not a problem. The thing is we should learn how to use that. That is something we should focus
Okay.
right now. So this is something which happens. Now this is the Kivana, this is the dashboarding solution, Elasticsearch for storage and searches, analysis, and Bit for collection and forwarder. Collection and forwarder, you can say agent. Now guys, what happens? Elasticsearch store the data uh, uh, in various format, but one of the format is like index index format. Now let me tell you, it's not a database. Index is a different concept altogether. Now if you ask me precise what index format and all, so there is a technology, there's a algorithm which is called inverted index. Let me Google it, it'll be faster. Inverted index. I'm not going through all the slides because it will take some time. So here, inverted index, and this is the algorithm. Again, there's a two types of index: forward index, inverted index. Now I'm talking about inverted index concept. That way, this data which is being stored is very effective, very efficient for the searches, queries, and filtering. Very efficient. Okay, so Elasticsearch stored in that data. So what happens? Beats store the data in a different format, and sometimes the data is not optimized, or maybe junk datas are there. Okay, the problem is like Beat has no intelligence. Beat will blindly capture the data. Let's say log file. I showed you, right? There is a file Beat are there, which will capture the log file and try to store in the Elasticsearch, which is a not formatted type of data, not organized. So that way, if you search the not organized data, not structured data, we call it a not structured data, then search results will not be very efficient, right? So for that, what to do? And that is where there's one more utility is there, which is called log stash. This is only for the logs, okay? Log stash. So what is the log stash is doing? Typically, what we do, we please hear me out. We collect the beats, collect the data from the different sources, logs, okay, and then forward to logstash. Forward to logstash. A logstash parses the data using stashing. Stash means stash the data in and put it in the structured format. And after the and here we have hundreds of algorithms we have parsing parsers, we can call it logstash parsers. I want to show you just for understanding purpose because it's a huge topic actually, to be honest. Okay, so these are the so many hundreds of parsers we have. See, here it is, hell lot of it. You see, different types of data you can parsing. Okay, so multiple parsers are there and it parses the logs, each line of logs in your desired format, whichever you want, and then send to Elasticsearch for indexing. So now, because you use a log stash and which helped you to, uh, bring the non-structured data to structured data. So now you have in Elasticsearch, and from Elasticsearch, you can through Kivana or through directly also, you can search to this. Are you understanding whole things? All of you?
Is there anything like for this log stash product specific extensions or libraries where it will be able to read the log and transform that into
Yeah,
structured
yeah,
data?
yeah,
Okay.
yeah. These plugins which I was showing you, these are the one. For example, let's say one of the popular one filter plugins. Let me show you. Filter plugin, one of these, like let's say CIDR. So this plugin will help you to fetch the CIDR from the logs and get this stuff. Or maybe one of these GeoIP, IP address which will fetch that from that logs. Grok, you can do anything. I mean, you see, simple statement. I think Grok you might have used in many other places actually. So parses unstructured event data to fields. So a lot of field, I mean, you have it, and you can keep scrolling down and based on the requirement you have it. Okay, so now this is the four components which we have. Now what is this? So this one, Elastic planned to add it on top of Kibana. What is this? See, I told you the evaluation how it has happened. So earlier we used to call it ELK stake, correct? ELK means E for elastic, L for logstash, K for Kibana, B is hidden. Then ELK stake, and then later on they converted into elastic stake. Elastic stake. Why they did elastic state? Because they released the cloud version of uh, Elastic, and they incorporated these many features on Kibana. I repeat, Kibana. So they started calling Elastic Stake, and now they are marketing little bit different, and that is called Elastic Observability. And you know what is observability? Observability. I'm not able to write it, but yeah. So this is the evolution of this family. So don't get confused wherever you are using different component, and that is how it is. Okay. So far so good, all of you? All of you? Hello?
Yes, go ahead.
Yeah. So guys, these are the two version. You can manage, self-manage. That means you can install all these component, or SaaS also there. SaaS is like a cloud version. Okay. So Elasticsearch, now you know that is been for storing, you know, searches and all. So it is highly scalable. Highly scalable means Prometheus is not scalable. It's an if you want to have a, if you want to store the time series database in a scalable environment, you should try to do that. Victor, there is one more tool has come, alternative of Prometheus, so like that. So Elasticsearch is highly scalable. That means you can create a cluster, sharding, replications, many features are there. So built-in searches, aggregations, DSL we have, and used by every major companies actually. Now let me tell you here in a simple way. You know that site searches means, let's say uh, I will go, let's say Flipkart, or let me put it my website. This is the my website, and this is developed in WordPress. And if I search for DevOps, see, I'm searching site searches. I'm searching on my website, and S is equal to DevOps. And whatever the results you see, this is powered by Elasticsearch. If you go to the Flipkart, you search for it. It's powered by Elasticsearch. So what happens? Elasticsearch primarily is being used for the website searches functionality. Okay, so like this. So yes, it's a distributed, fast, highly scalable document database created by Shea Benon in 2010, and so on. Now Logstash, I explain you at a high level. Logstash is one of the component for what? For aggregating, filtering, and supplement log data. Now, once you process the data, we parse the data, and Logstash can forward the altered log to the Elasticsearch for storage. Okay, Logstash we use it. We discuss a little bit of it. Sending a logs directly to Elasticsearch without Logstash can lead to inconsistent data. So we understand. Kibana is a dashboard. We understand that. Web-based front end, we all work through the Kibana. Work easily with Elasticsearch for charts, graphs, and visualizing the data free from the Elastic company. So almost all the components is free actually, to be honest. So like that. Beats. I showed you right the page. So beats are like a kind of, you can say, agent, small, lightweight utilities for reading logs from a variety of sources. Usually send data to Logstash. There is a file bit for log file, metric bit for OS Linux one, packet bit for network, log bit for Windows event, and few more. You can write your own bits as well. And now this is the overall architecture. So if you see that, uh, everything you will feel meaningful. And here, this is one machine. This is another machine, or you can install all bit in one machine also. That's not a problem. 4 machines just for representation. And these utilities taking the data. This is a log. This is mattress. This is mattress. This is the mattress event, right? Remember melt, logs, matrix, events. Okay, is sending to the Logstash for processing. Logstash will send to Elasticsearch, and this arrow is wrong actually. Okay, so they should be opposite way like this. Kivana read the database, and this is you. You will work with Kivana. So this is the architecture of entire Elastic Stack. Okay, little bit more in detailing if you want to see. Logs sent by collected by beats. Beats can send to Logstash. Now here you have a Kafka. Why? Because sometime what happens, Logstash cannot stash all the logs at a high speed because it required lots of compute, right? So you can use Kafka as a cache for time being queue and send to Kafka for, processing little slow and not utilizing so much of hardware. And the Logstash will send you Elasticsearch, and Kivana will back and then search for this, something like this. Okay, so far so good. Any questions, any doubts?
Rajesh, how about Fluentd? Fluent.
Fluent D will come in place of Logstash D.
Okay.
You,
Okay.
if you want to compare Fluent D, then you should
Mm-hmm.
compare with Logstash D, because many people are using Fluent D, many people are using Logstash. It's up to you. Both
Okay.
is not required though, because duplicate tools, right?
Mm-hmm. But we do need
So
the beats,
many
right? Beats is the collector, the agent.
a beat. I mean, I'll discuss because there's so much changes has happened over the period of time. Even
Mm-hmm.
I am finding little challenging actually. So here you
I'm
see
actually I'm
earlier.
confused between which one to use. So
Yeah, I understand that. I'll simplify this. Just give me a few more times. I'll simplify
okay.
because there's so many changes happen. So here, if you see that earlier we used to call it ELK, but many people also started using EFK. What is EFK? Just now you said. So instead of Logstash, people are using Fluent Bit. So don't get confused here. Fundamental, the requirement is same. The
Okay. Okay.
component they are changing.
Got it. Got
Maybe Kivana you don't like, then you can go for Grafana also, because Grafana support Elasticsearch, if you remember yesterday. Correct now?
it. Mm-hmm.
Right. So like this. Okay. So now what they did, they want, because all these softwares we had in open source, right? And Elastics were community were developing. But what they did later point of the time, they see the market is going towards observability because SRE become very popular. SRE means observability. Observability means, remember that you have to monitor infrastructure, you have to monitor the trace, APM, synthetic, and then logs also, security also, and a lot of things every day we are getting added actually. So what has happened, because people were, I mean, many engineers, no, were hating ELK because of so much of tools loosely coupled actually, though it was a well-defined architecture, but it was not easy to do that because Datadog has come up with a one age. I mean, Dynatrace has come up with a one agent. AppDynamics also has a one centralized agent for everything. Datadog also has one agent for most of the things. Neuralink also have one agent for most of the things. So now they have started making the user SRE experience much less better actually. So then Elastic also thought, let's do one thing. Let's not have so many utilities for each and everything. Let's migrate everything to one. So now what we had last, we had a file bit, metric bit, heartbeat. I showed you endpoint for synthetic, win and many other. And what we did, they migrated from all these bits to one agent concept. And now we got to elastic agent. And this agent, you have to install only one agent now in the current format. And then this agent can do the logs collections also. This agent can do the metrics collections also. Synthetic means uptime also, APM means trace also, and Windows data and security also. Everything you can get it done through Elastic Agent. So one thing to install, configure, manage, scale, and secure. So now they started calling, because Elastic Agent, you have got it right. So they started calling, instead of ELK stake or Elastic stake, they started calling Elastic observability. Observability. Remember, observability means melt data, three types of data you have to collect. Yesterday, I mean, last session we discussed. So they started doing that. So now, did you understand that the transformation?
Rajesh, I have query. Like earlier, we
Yeah,
have to install the different beats, right? So now we need to install the one agent. So does it mean that one
Elastic
agent,
agent.
yeah, Elastic agent, does it mean when we install the Elastic agent at the backend, it's still installing different services or the beats, like file beat, metric beat, heartbeat, and
See,
managed by Elastic agent?
actually, the code will be, of course, some of the common code, right? Because here we had a different code in a package in the different executable. Now they combine it, so definitely the code will be more or less a common code. But right now, for us, like, you don't have to install multiple one. You have to install one which will do everything. Simple. So how internally they have merged the code, probably that is not our concerns right now, because
Okay,
even
so
I don't
reason
know, to
behind
be
I was
honest.
asking when we, when we search for services called Elastic Agent, do we also see the agents like FileBit, MetricBit, Heartbeat like that?
Ha. Search, yeah, search results. That's the reason I told you, no, from last couple of years, so much transformation has happened in the Elastic. I used to also get confused, but somehow now I'm stable. But yeah, Elastic Agent will do most of the part actually. Now, that means, in a simple way, if I say, if you want to set up observability, it means you want to collect metrics, you want to collect trace, you want to collect logs. Metrics from infrastructure monitoring, trace for APM and synthetic, and logs for the logs. So agent is sufficient. One agent is sufficient for it. Make sense?
Actually, I was looking answer like when, for example, if I run a PS3 command, right? Under the
Mhm.
PS3, will it showcase FileBit, MetricBit as a services or as a uh, processes, different processes, or it only showcase one single process or service called Elastic Agent?
Okay, so you are saying, okay. You are saying like Elastic Agent process will ultimately install all this internally and
Yes,
something like that. Okay,
yes,
so
yes,
that,
yes.
I think I have not got into that mode of it. Probably we can do that some uh, discovery on
Uh,
that.
Okay.
But
Are we
yeah,
going to do
but this
practical for this?
yes, we'll do that.
Okay.
But for us, I'll tell you, for us right now, we have one web script which will install the Elastic agent in one go and run the services. So for us, it's just a one executable, one command to start and stop the service, and there is one configuration file which I'll talk about it. But ultimately, let's say your question is like, when you run Elastic agent, are they have the some of the child processes which is again running all
Correct.
these things? So
Correct.
must be
Correct. Okay.
must be.
Okay.
I
Thank
mean,
you.
because it's a same code, right? They have merged it together, so must be. I'm not sure. I'm not seen the child. I mean, I'm not got that curiosity, but yeah, must be.
Thank you. And are we
Okay,
going to
so
cover the, how much resources are required as a standard, Elasticsearch agent? What should be the configuration of the
yeah,
system
so
or the server?
yeah, yes. This agent has been tested very well. The requirement for the agent, I can show you. There's official documents available for it. Very minimal
Okay.
CPU and RAM is required, and disk space is 100 MB actually. So yeah, these because this is a one of the they are trying to sell the software now. So all these they have it ready. They have it. Yeah. Okay. So now if you see that now little bit new has come now. What is that? So if you see that little bit carefully, you have a Kivana, which you know that, and then Kivana searches the Elasticsearch, which you also know that. Now Elastic Agent send the data to Elasticsearch now that we know that. Okay, so please understand that Logstash is not required here. Why? Because the reason is Logstash is not required here. Why? Because we are talking about observability, not only the log search. Earlier we were discussing the log search. Now you need a trace. For that you don't need a log stash. You need a matrices. For that it's not don't need a log stash. Why? Because these are structured data. You need a log stash whenever you have a non-structured data. Okay, please understand that. Raw data, not structured data. So here directly a agent can send the data to Elasticsearch. Now, so in real time, what will happen? Elasticsearch, Elastic Agent, you have one configuration file. Okay, I'll show you that during the demo. Each Elastic Agent, you have a configuration file. This configuration file, typically in Elastic, we call it a policy file. Policy file. Okay. So now what happens? I'll tell you. Let's say you want to enable something to hundreds of agent. Okay, hundreds of agent. You want to enable something. What to do then? Are you going to modify hundreds of agent? Okay. Are you going to modify hundreds of agent? How? Anyone would like to help me? How? Let's say there's one agent, there's one more agent, there's one more agent, there's one more agent, and each agent you have a policy document, configuration document, and I want to add some more monitoring. And for that, I need to modify this document. How do I do that? Any idea? Any idea? So guys, we had learned, right, this tool. I think you should tell me. Let's say I want to change software in hundreds of server. I want to change the configurations of the software in hundreds of server. Which tool we should use it? And we know that we have
Ansible.
done.
Ansible,
Yes,
Ansible.
yes. Ansible, Chef, Puppet, CF Engine, all these tools are there. Yeah, so that is done. But you know what, guys? Elastic have developed one more software, and what they call it, Fleet Server. Okay, Fleet Server. So this is another software they have developed. What Fleet Server is doing? Fleet Server will see here. Please read this message. Take the policies from here. First you add this machine to the Fleet Server, and here you added this machine to Fleet Server. After that, it will take the policies from the Elasticsearch, which is server, and then apply it to the each Elastic agent. So Fleet Server can be used to push the configuration file to each Elastic agent. Now Fleet Server can be used for Kivana also, because in Kivana also you have multiple Kivana. If you have a large organization, you have multiple Kivana. So that way also is possible. Okay. So whenever you come to the fleet server, please understand fleet server is for modifying all agent server and their configuration from one centralized place. Okay, that's all. So this is something we should remember that.
No, from
So
fleet server
while
only we
demo,
can install the agent as well. So
fleet server, yeah, fleet server also, you cannot install agent. Fleet server, fleet server, you can modify the agent behavior,
only
modify the agent
configuration,
behavior.
that's it. Okay. So installation we have to
Configurations.
use our Ansible or any other tools only, right? Agent installation.
So you can use agent Ansible also, but many of the times what we do, we create a golden image. Okay, I mean talking about the real practice, golden image, and in the golden image we have already the agent installed. So the moment agent installed, automatically that you create a one VM, let's say this one, so agent will be there and automatically it will get registered to the fleet agent automatically because the service is created and configured in a golden image. That is how you do that. But manually, yeah, you are right. Ansible you can do, manually you can do whatever you like it to do that. Make sense?
Yeah, that's correct. Okay. Because of this golden image only we implement when we are doing in the new server deployment. If it is on the
Yeah,
existing servers, I think we have to use that. Yeah. Okay.
true. Yeah, true. Yeah. Okay, so that is the fleet server. So remember that keyword, just remember that. Anyways, I'll show the demo for that. So you'll understand. So now you understand that here is a fleet server you see, and managing the agent and updating the policies and all everything. So this is the workflow of the field server. Okay, so now this is something you can say Kubernetes, stuff. So how do we use? I mean, the question if you're asking, Rajesh, I want to set up observability, complete observability, using Elastic, not Elastic any Stake anymore, using Elastic now. We call it observability, Elastic observability. But because all of our platform is on Kubernetes, so how can you do that? So that is where we have every components. Now see here, this is the agent which will help you observability, which you can find the Kivana. These are the beats, also individual components, which will help you to observability and which you can find Kivana. So basically now in the current format, you have everything. Elastic agent also you have it. These also you have it. Kivana you have it. Elasticsearch you have it. And whatever you want to do. So every features is available right now in the current format. Okay, so now this is a special image, and this special image I want to show you, discuss a little bit. So this is for the how to gather the trace, how to gather the trace. So trace, I'll discuss, maybe I have not discussed the trace right now in detail. Once we get into the app dynamics and dynet trace and new relic, I'll discuss about the trace because that's the fundamental use of it. But I'll put it in this way, in a simple way. This is you end user, and you hit www.flipkart.com. So it travel to DNS, to load balancer to web to app server, to DB server. Now it can be hundreds of different traces also. So this uh, second which is been used between the two different point, these are all called traces. Okay, so we need to capture the traces from the specifically program means, let's say this is your applications, and this applications I'm drawing a large boxes. Now this is the main class, main method. If you remember public static void main Java programmer, if you remember main method, another method, another method, and now between this method to this method, this method to this method, this method to this method, how many milliseconds has been spent, this also I want to know. So this is called, this process we call it a APM, application performance management. And this whole tracing activity you can also do synthetic and run. So slowly we'll get comfortable with it, but right now this APM need to gather the trace of from your program, which can be in Golang, Java, Python, or other languages. So there'll be one APM agent is been given by Elastic. Mind it, the APM agent will be different for Go, different for Java, different for Python. So Golang APM agent will be in a Golang. Java application APM agent will be in Java, jar5. Python code, Python applications APM agent will be in a Python code. So then will they can get the data. This is called instrumentation process. Okay, this whole thing is called instrumentation process. So now what will happen? You will configure the agent with your applications, and this agent will send all the traces to what? To agent. Which agent? Elastic agent. An Elastic agent will store in Elasticsearch, and then Kibana can see that all this thing. So now what I was trying to tell you, if you want the trace in Elastic Observability component, you have to install the APM agent. You have to instrument your code, your application using APM agent. Are you understanding all of you? All of you? Hello? Am I connected, right?
Yes, it's fine.
Okay, cool. Okay, so now one more slides I want to show you. This is the difference between ELK stack, Elastic stack, and Elastic Observability. So more or less you have understood that at a high level, but yeah, these are the some of the differences what you have for that. Okay, so we'll not get into so much deep, but that is for visualizations. Okay, so now I'm going to help you with some demo. So what I'm going to do, I am going to um, uh, show the demo of all this whole process. So let me create one VM, launch. So here I'm going for this and ELK, or you can call it Elastic, whatever you want to call it, 22 version. And I'll go for 8 GB RAM, so that way I'll not struggle for CPU and RAM. And I'm allowing everything for time being, okay? So default. So bad practice, but right now I don't want to talk about those best practices, but the functions of tools. Okay. So this is the machines. Let me go to putty. Yes. Colors and Ubuntu. Now guys, here one thing you need to remember, okay? And what you need to remember is Elasticsearch you cannot run as a root user. Okay, please remember, Elasticsearch you cannot run as a root user. So for that you have to use a normal user only. So I'm going to use normal user Ubuntu itself. So now what to do? So you can go and their website and then you know do all these things. But right now I have all these notes which you know how to get it, and which will help us to save our time instead of going here and there. Okay, so this will help you to install the Elasticsearch step-by-step guide. Okay, so this is for 7.x, this is for 8.x. Okay, and 8.x. I want to check that Elasticsearch download, which version you have available, whether 8 or 9, because so many release nowadays is coming, and I'm not getting sufficient time to keep in a pace. So 8 only is there. So that means I'm going to use this tutorial, this one. Okay. So I'm going to download this utility, enter. It's a pretty huge file, but on AWS it will be faster. So like that. I'm installing Elasticsearch minded. Okay, done, guys. Now here I'm going to extract it, and then go inside the directory, and this command will help you to find out the Elasticsearch configuration file. And I must tell you, this file is most important one. Okay, for configuring the Elasticsearch, this file is most important one. So you should spend some time with this file, and these all are YAML file. Okay, and I will go inside the bin folder, and I'm going to start this Elasticsearch. This is the command to start the Elasticsearch. But you know what? I don't want to lose my console, so I should go for one command which will run in the background. But the problem, you know what? There is a one more problem which we have. So if I run in the background, I will not get some of the root token. There is a way to get it in the log file, no hub log file and all. So I'll do one thing right now. I'll not complicate, run it directly. Okay. So this will run the Elasticsearch. Just wait for a second, and see here. So it seems everything is okay. I don't see any warning or error. Info is coming everywhere. So should be good. 8 GB minimum. Okay. And good. Yeah. So here I got this, everything is green, you see. So cluster health, one node cluster it got created. So everything is green, okay. But why I run it not in a background? Because I wanted this one, and I want to copy this one. What is this? So let's spend some time here. So here your username and password, where is that? I'm just trying to locate the username and password, and here it is. Okay, so mind it, your username is Elastic. One time password is created here. You can change the password also, that's not a problem. And where is a token for Kivana? Here it is. You should read this. Okay, And if you want for enrollment token, if you want to attach the node to this cluster, though we don't need it, here it is. This is the command. So more or less we got this stuff. Okay, so now I will open up another console because this will I lost it, and Ubuntu, and I'm going to test it whether cluster is up and running or not. So how do I test it? So you should run on this command here, and the default port is please remember running in the local host, and the default port for API of Elasticsearch is 9200. Now you know what, 8 version it has some certificate, they enable by default certificate. So here I am calling the certificate. You can use the username and password also, that's not a problem, but certificate is okay. Enter. And what is this password for this? So password is, I copied here, elastic copy, enter, paste it, done. So now that means my Elasticsearch cluster, one node cluster, is perfectly running fine. And you see that everything, you got the information, name of the cluster, these are the version information, and good to go. So that means this is my cluster which is running perfectly fine. Are you okay with it, all of you? Hello, are you okay with it? Okay. So now guys, next thing which I'm going to install, and that is Kibana. Okay. So can we go ahead and install the Kibana? So same way, I'll go for Kibana, install devops school. Okay. And if you see that, this is the older version, which I don't need it. I need 8x, which is the latest one. I need this one. So 8x, that is done. So this is for 8x for Kibana downloading. And if you want to configure it, you can do that. And this is the file which we have. So I'll show you this, all this demo. Okay, so now let me duplicate. Same machine I'm using for Kibana also, Ubuntu, and I can become a root for Kibana, but you can run it non-root also, mind it. It's not like only you can run as a root. Kibana you can as a non-root also. So here I'm going to download this version, latest one of which, Kibana. Okay, and then extracting it. Almost done. And now these are some of the tricks to see the changes, but right now this command is required. Okay, so you should check this file which is under the config directory, kibana.yaml. I want to change one thing, let me do that. Kibana config and vi kibana.yaml. So I want to change URL, but I believe it will be done automatically. So should I leave it? Private IP where the Kibana is being installed. So let me change this. Server host, and here Okay, so actually that is correct, but you know what? The problem will happen when you try to access this Kibana from outside. So then it will have a problem. So let me do one thing. Let me set the IP address. IPA. Done. So this is a private IP address, okay? And the port number is 5601 for Kibana. Remember that. So good to do that. And if you see that, if you read this, I did this here. And then this command to start as a root. Though, as I said, you can start as a non-root also. That's up to you. So bin, inside that bin, there's one utility which is Kibana, and allow root is needed when you are starting Kibana with the root access. Enter. And I did passed. Oh, spelling mistake actually. Done. It will take few seconds of time and done, guys. So now your Kibana is running here, and you should copy this whole things and put it up here because I'm from outside, right? So I'm going to use IP address which is public one. Done. And you copy as it is, okay? So done, and open this URL. This is your Kibana dashboard, okay? Just hold on for a few seconds because it's running.
Maybe you
I'm
forgot
just
to
waiting.
one comment the IP address on the config file.
Oh, is it?
Yeah.
Oh, that could be a major mistake in that case. Control C, and let me check this because it's running perfectly fine, but it's not accessible from outside. So that could be the region. So vi config Kibana, and yes, you're right. My bad. Oh, what happened? Uh, Done. And I did this. Yeah, now it should be. See here. So now I can use the public IP address. Refresh. Yeah. So my Kibana is also now running. Now you know what? So Kibana need to know Elasticsearch. Okay. Kibana need to know Elasticsearch. So how do you give it? So you can manually configure it actually. This is the place you can manually configure it. But why to manually configure it when you have got everything already? See here, this one. This token which you see is basically have everything encoded actually properly. Everything, the address of Elasticsearch and everything, and certificate and everything. So let me copy paste this one and configure Elasticsearch. That means done. Now, if you're saying, hey, if you're the owner of this, go here and run this. Just a second, guys. Run this code cdopt cd kivana and give me that. So more bin kivana, that was a window path, okay, verification. And just a second, let me run this. Linux, right? Here it is, 288.273. 288, what was that? 288, 273. 273. Done. Guys, now you know what has happened. Kivana is configured with your Elasticsearch. Both are separate component, but now database is configured and this is Kivana. Now username is admin and admin, if I remember correctly. Let me validate. No, oh, sorry, my bad. Not admin, Elastic and password. So Elastic username and password, I'm having it actually. So here this is the password and done. Now this is your Kivana configure with Elasticsearch. So far so good. Any questions, any doubts? All of you? So here you can add integrations, but you can click on the explore my own, and now you need to learn this dashboard. Well, let me tell you, a lot of features you have it, okay, but we'll focus on observability. That's our target actually. Okay, any questions so far?
No?
Okay, so now guys, next thing which we have is like to install the Elastic agent. That is a one step which is we have to do. Then we need to explore the data which you have got it from the Elastic agent. That's the second thing. Third thing, we have to create a dashboard. And fourth thing, we have to create alerts. So these are the 4 activities we have pending for that.
Have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.